Okay, so let's have a look.
So, she said we can go over. So, like, we look at the budget, what we can look at, policy of the code. There's a 50%
I think I'd like to take these up here. I invite everybody to come up and take a look. What we're going to do today is finish up our leaf lab, which will just involve a little writing from you and probably looking at the chromatography results, which I have here in front of me. They came out really good. And then we'll start a new lab, and I'll have you more or less design this lab. I'll tell you about that maybe after we go through this portion of what we're doing today. Okay, so maybe I can do this cleverly. There's already oh man, come on. All right, and I can use that as a pointer. Okay, so as you can maybe even tell from where you are, but I'll give you a chance later to come up and check them out. They came out really good. It may not have looked like much while it was running, but you can see on all four of these actually what? What do you notice? Probably from even where you're sitting. What can you, especially if you've done chromatography before. 80, what do you see?
Well, I'm not sure how special it is, but all of them look like brown at the top.
Okay, so I got a brown portion, yeah, or brown green. Oh,
So definitive layers.
all right, that's really important. You've got definitive layers. Remind me, somebody, what does paper chromatography do for you? What does it do for you? So,
Does it separate out?
yeah, it separates chemicals. So let's remind ourselves, because it's an important point to have clear in our heads. We had two phases. The one was the water, and water is what sort of substance? What sort of substance? Alicia? Polar. And the paper, probably, Alex? Non-polar. So let's think about what this means. The brown layer that Aiden, you just referred to, right? The brown layer is probably more of what sort of quality then? Because here's the bottom of each one. So the bottom, the brown layer is probably a chemical that is more what? More polar. Yeah. Okay. So, I don't know if you drew these or not. There's lines at the bottom of each one. I think those are actually there, or did someone draw those? No. Okay. So what might those be at the bottom? Although incidentally, there's some up here on this one too. But what might those be at the bottom? Anthony?
Non-polar.
Yeah, pretty non-polar stuff, and it's remaining stuck to the paper right where it first touches it, which is interesting. I'm not sure what that is, unless it's just one of the two parts of the molecule. Two parts of the molecule that we were more or less analyzing. Of the chlorophyll, thank you. The two parts of the chlorophyll molecule, right? But the other thing is, and it might be that some of those same items especially come up for, this was, Chelsea, this was you and who that had the black? With Lola. You and Lola had this. And when you come up here, folks, notice that there's black stuff or dark stuff at the very top. That's interesting because if you have some solutions, you might have some things that actually kind of float to the top anyway. which doesn't necessarily tell you about the water, but could tell you about the density of the stuff. You know what I mean? So this would be stuff at the top here with a very density. If it kind of rose up, riding, so to speak, on top of the water, Ellen? Very low density. And I think in the reading of the lab, am I right? They talk about what some of those materials could be. Well, they don't talk about it actually. All they mention are the pigments, which you see more in fall, by the way. Although you may be seeing some pigments here in part of this as well. These are what these black bits are insoluble chemicals. Oh, there is it. Where is it? Ah, thank you. Okay, so it is in there. Hallelujah. Okay, so tannins. Yeah. So these are insoluble parts. For example, oh, what is it? Sorry, sap. Sap. So sap has a lot of tannins in it as well. Some of these insoluble parts. Yeah, so the floating parts ended up at least on Chelsea and Lola's, and some of the others, I think some of those same things might just be stuck at the bottom. Maybe they were of a higher density, so they didn't really move up with the liquid. But I think that divides at least the two parts of the chlorophyll really nicely. I don't know if the brown is a pigment, Aiden, or if it's just one of the two parts of the chlorophyll and just looks sort of brown because it's dried and appears a little different. But we definitely had some nice layers. On the other hand, this is like two different grains. That could be part of the chlorophyll. And maybe the brown is actually a pigment that's coloring a lot of the leaves. Chelsea, you and Lola, what sort of leaves? The fleet or the lilac. So I didn't know that about lilacs, but obviously they have a lot of these tannins in it, don't they? Because they really rose up more clearly in that one. These two are kind of similar. AA, who was working on that? Aiden, what kind of leaves did you have? Do you remember the tree or anything it was from?
I remember where it's like in the back there by the.
All right. You don't know what kind of tree.
The leaves have like kind of like a maple leaf.
Okay, well, if it's a maple, that might have been fine. Okay. What about this one? A and E, Ellie? Is that you? Oh, that's Arrow. Arrow, what kind of tree or whatever did you guys have?
We chose that one right there.
The one in the middle?
No, the one right.
Okay, so what is this, folks?
We have the same color. Yeah.
It's a real classic leaf shape. It's all like it's a little natural history, don't it? It's an ahorn, it's a maple. Which are nice colors and fall. Okay, so you got a maple, so we may have one or two maples, which makes sense because they're really, really similar. What about my last group, AAFE? The big one right here?
Yeah, the one.
The one is true, that's right. All the same?
Yeah, I think so.
Okay. And at least the one I see here, looking straight at us,
Yeah.
the leaf shape is like that. So how does the leaf shape?
Then I love that.
Kind of like
Yeah.
that. Is that right? I can't tell from here. I have to be closer to the leaves, but you probably, the leaves are gone. Or they're so dried up I won't be able to. Anyway, I should have had you identify those more clearly. That's my problem. But this is not a bio class. I'd have to teach you that some other day, which might be worth doing sometime. Maybe I'll do that with you one day. We'll take a walk around the park and you'll learn tree identification. Would you mind doing that in spite of the chemistry? Maybe we'll do that someday because I've learned most of the trees. And I can show you some things about their bark and stuff too, which is kind of interesting. Okay, well, anyway. So that should enable you to at least write up some stuff about the chlorophyll and what the chromatography does for you and what some of the different parts are. So when everybody, maybe I'll step back and you can wander up and have a look. And then when everybody's done, take yours and one of the 2 or 3 people in the group tape it to your paper. And each of you could even point to some things and say something about it. Oh, this is the polar part, this is a non-polar part of chlorophyll. This might be a pigment, this might be a tannin. You know what I mean? Okay, and that'd be a good way. So let's take 10, 15 minutes to kind of wrap that up, and you can ask me questions about the writing. And then I'll say break, and we'll take a break when a lot of you are done, and I'll introduce the new lab. The new lab we won't finish today. We'll have to finish it tomorrow because, well, I better not tell you that. Okay, anyway, because you're going to figure a lot of it out yourself. Okay? All right, so get together with your partner or partners. Lola's not here. Could you? That would be really helpful. Okay, good. Okay, so. Bella, anybody there? Be quiet.
There's one person online, and that could be Mr. Weiss.
Oh, is that how it works?
I have no idea. No one has said hi. Doesn't look like anyone else.
Oh, yeah, ours is started by far. I'm just kidding. That was for our like S2. It's like horrible. Ooh. Wait, Mr. Weiss?
Yeah.
We should run this table.
I got some tape. If you need some tape, you tape that to your. I don't expect you to make the right deal, John. Just don't let your hand from it, but let's not worry about trying to go crazy right now. Just try and learn some of the concepts and Chelsea you can show them.
Yeah, sure. I'll just like how to do it. Like, you know, like, no.
Okay. Okay, let's get rid of that.
That's what it says, stress us to accomplish the progress.
Wait, what color is the more non-volatile one?
No, I think it's the lower, the higher. So the one on the bottom.
Okay. So it's more
The first one is the first one that. You said the first one that-
I thought the top was more color.
Or maybe you said that.
Yeah, the bottom is blue.
The darker one was the purple.
Yeah, that's true.
The darker one
So you
was lower.
you can be lower.
I mean, for us, I think it's
So we don't give them.
yeah.
Just look at Chelsea. Go take a look. Look at Chelsea's data. Look at Chelsea's because they don't want to get really the 10 very top. You should see that.
It gets darker, it gets lighter at the bottom rather than
Don't say.
Well, these are Christian. And don't they, ones on the table and the paper guy, these may not
Yeah.
Yeah, I mean, yeah, if they tell you that, let's take the back. But I don't think there's Anybody there? Yeah, there is. Amina, if you want to. Okay, thank you. Thanks for telling me about Louisa. If you want to join with a group, you certainly may, Amina, and talk to them about the leaf chemistry lab, and then we're going to start a new lab today. If somebody wants to work with Amina, you may certainly call her and include her in a group. So I'll leave that up to you. Oh, well, you just don't.
My question is,
No, I don't think so.
you don't have to take part.
I don't think you do, because you don't know that, and probably something else on the drive, you know, it may not perfectly match up with this one. This one may look like, but, yeah, so like the one here, when it's going to the bottom, the compound said a lot of colors, this color, this one price, it's not what it's not. But you can probably see it. It's probably not what
There's not like one. I think so.
as you're describing it.
Forward.
Chelsea, what was your lead again? What, right?
Yeah, like,
Lilac.
lilac. What? Okay,
You're supposed to compare leaves.
wait, what was your name? Maple, maple?
Yeah.
So they're within the box.
You know what, Penelope, Ellie, why don't you go out and just get a leaf and we can see what it is? It's not far. That'd be cool.
Actually, yeah, like
What leaves you?
lilac.
LIC? What is it?
Yeah. LILAC.
Okay, so I got the leaf from Aunt Sophia and the rest of their beef factory. That's this. So I believe that's a poplar. 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 LAR. Poplar. Or poplar. That's the only word. Thank you. Thank you. That's okay. Super. Okay, good. So I'll see if other groups are done and then we'll.
I did. When you're done, you can just hand in your labs to me, and I'll let you know what groups are kind of finished, so if you guys are done. You guys are done with the table. Thank you very much.
If you guys, what do you guys study for like, do you have specific for you or? Yeah. Like, what will be, yeah. But I like
Okay. Bella, this is so old, it's shocking, but I just haven't seen it for a while. What's that?
My name is Uncle.
My name is on both, which is nice, thank you. Appreciate that. I'll give you a minute or two to finish up, and then we'll talk about lab two.
So,
You can see one, here's, oh, maybe not, here's Amy's. There's the one from Bowen. And Janine. It's the only one I got, the others are still out.
Wait, one second.
Is that two? Thank you.
It's both in part A and part B.
Super. Okay. Let's go ahead and even if you're not done, I'm going to interrupt you, and then you can either work in same groups or switch up if you want to change. That's fine with me. Let's talk about the chemicals. Your objective for this lab is to figure out the concentration of this HCl. The only thing I'm giving you, other than a limit on what you can take out of here, is I've got chunks of calcium carbonate. So your objective, so what could we call this? We could call this concentration of HCl lab. I'll give you that. Materials, so I'll just tell you, you get CaCO3, solid. Procedure you're going to figure out, but under data, I'll just let you know because I only made so much of it that we got what, four groups. Four. All you get is 40 milliliters because I don't have enough for groups to get more than that. So measure it out carefully. I'll have it in the back. But frankly, what you've got to do first, and this will take probably the most time, is you got to figure out how to do this. And it's going to involve some chemistry and thinking and a reaction. And so first you're going to discuss that with each other quite a bit. I'd like to let you figure it out. If you're really hung up next period, I can answer a question or two, but let's see if you can figure out, because it's an AP lab. And then probably the procedure, even if you don't finish it today, it's okay, we can finish it tomorrow. All righty, Daddy? So the crystals I'm going to have back by the scales, the CaCO3 limestone crystals. I'm going to put by the back here a nice graduated cylinder and HCl that's labeled. So you'll know that's what it is.
What I want to know is how
start writing part A.
I think probably.
Okay, and before anybody starts, show me your plan, so I can say yes, yes, or no.
There's something about last time we used it.
Well, we did one test with it, which
Yeah.
was, I blew into a straw that had CaO, and when I did that, when I put in CO2 from my breath, then it interacted with the CaO and made them from CO2, and then it got cloudy and melted off.
Right.
So, but I'm giving you the crystal ball, right? But that's a good thing to keep in mind, though. Very insight.
Or okay, what do you get like a
Well, then we just have to convert the solid into the liquid. And we'll just have to write the equation. Compare concentration of the feed.
you start adding like some of the
Well, you would do it like,
And then whatever started off, I have to react. How is it gonna react? That's what I'm thinking about. And then or
well, you would have to write the equation.
something.
Yeah.
Oh. So basically, So if we slowly add so we can see how we get different after reacting and because we want ground we can find the mold and then just go off the reaction. It should be the same
Also, the only problem
And the CO2
Even on her,
It's like a one.
So then
We have to fix this really.
Okay, so let's see what I
I need your, well, your grades and whatever else here. Okay, so
yeah,
let's see.
great. Because I mean, obviously, it's a really important year, and I want to figure out how I can do the best possible
Yeah,
that I
yeah.
can.
Okay, so,
And it's obviously still the books I'm taking the AP exam on June 10th.
right, and that'll be, to be honest, that'll be a big part of your
Yeah.
grade. So just try and get as much done in the book as you can. Ask me any questions you want, that's fine. And as you're studying, you can also ask me questions too, all right? So feel free, especially next week, we have oral obby, so I have time to answer questions.
Okay,
Or even do
I'll
a live meet or whatever if you want to talk
Thank
about
you.
stuff, okay?
do you think there's a chance that you get a 2+ in my report card still?
I don't know, because I don't know, okay, first off, I don't know what you got for anything. For the, well, yeah, 3 on this thing. So we could do them, so that's a third, and then you'd have 2/3, either 1 or 2, depending how you do on the rest of it. So let's look at the rest. See, you're all complete with labs. There's nothing missing there. And I can't quickly do the calculation in my head.
Should be right.
And then this is it. This is the book, and that's kind of the other thing we got this semester. And that's all going to be filled in
Yeah.
from 1 through 7. Those are 30 points apiece, so that's going to count a fair amount. So assume
Say
those
best
go
case-
pretty good,
Say best case scenario, I get near full points on the book.
then you're going to be really good. Then you'll probably have some sort of 2 for the semester. That's my guess.
A 2. Even if anyway, I looked it up.
I don't know, because I can't do that math in my head.
Okay.
So I don't, some sort of 2, but I don't know what it will work out to. 2+ would be great. Like I said, you can do the math and put in different scenarios. I don't know that right
So
off
what
the
do
bat.
the other 2/3 account for?
Well, it's 2/3 argumentile, and that's 1/3 your causative.
And
So you
then
got 3.
argumentile is-
Here, we can do it this way. Okay, so you got a 3, which is like 8 points maybe?
Yes.
Okay, so, and
Do I want to get my calculator?
you want, no, we'll just figure this out. You want,
I want 12.
and it's 1/3, 2/3, 2/3, so we got X, and then it counts twice, because it's 2/3.
Right.
So we just do it that, right?
Yeah.
Okay, so we got A plus, this is kind of fun, so we got, 8, we can multiply both sides by 3, so I got 36
Uh-huh.
equals 2X plus 8. So, take away 8, 28, so we got, 2X is 28, so you gotta have a straight 1 on your argumentile, which is possible.
Okay.
If it goes well on the book, that's a lot of the points.
Okay, great. And then, okay, so it's the book, and then is there anything else that can?
Any other labs we do from now on,
Great.
but, I mean, they're gonna be pretty casual. Thank you, Chelsea.
Cool. So
They're gonna
I-
be fairly mellow labs because I don't need them to be so intense.
Okay, great. So
Yeah.
we'll aim for that.
Okay, good. I don't.
I'm figuring out how I get a 2+. Okay, so we have.
You gotta- It's not bad. So I'd say balance your equation. Otherwise, you won't work.
Well, not with. I'll do it. There's 2 foreign. Water. There's 3. There's 1, 2, 3. There's 1, 2, 3. It's balanced. Mine was 3 plus 3 is 4. Form.
Mr. Weiss,
Yeah,
for your final grade on your report card, the first semester and second semester are averaged out.
no, I don't think so for you guys. It's just per semester.
Oh, okay, there's no final grade.
Not to my knowledge. There is for
Okay.
10th and below, but I don't think there is for you guys. I think it's just a semester grade.
Then which accounts for your GPA?
I don't know. Probably.
All semesters are averaged out. I think so, but for each grade, like year, both semesters are averaged out. But for the 4 years, it's all averaged out. So everything that you got for the 9th to 12th grade is all matters. So.
Don't they just do your GPA by semester anyway? So you got like, 16 semesters or 8 semesters or whatever it is. You got an idea from the equation what's going on? Yeah, good. Now we can start thinking about it. Good. That's the way
Is there a way to like measure the pressure? And how? Oh yeah. And then something how much you have like oh, we put out and it will stop dissolving. And then we just have to make different things.
Okay. Figure it out.
Actually, you didn't. 40 millimeters. 40.
Oh, yeah.
So, the more of that, the CaCO2 wasn't running the chunks of that part of yeah, well, I've already beyond that. Yeah. You've already figured out how to do it, right? You're gonna measure this before and after. You got to get going pretty quick. So, before we go, let's see. So, yeah, I think you'll see them from the last thing. Okay? All right. Good. I've got some matches. You guys figured out?
No, the difference is. So, we're going to.
So CSA trees and use like a small beaker, put the 40 milliliters of acid in there. And you really need to do it. But don't pour it around it, the whole thing,
Can we get matches and
yeah, the gas is on, matches are there right now. Matches are out there,
Yeah.
gas is on.
this is how we know when
Or goggles,
Okay, get your match? Yes, yes, but 2-1, right? Okay, so that might be, see what we do for this. Exactly. And we measure the full match.
let's run it over there.
Right, so this is gonna dissolve a little bit. So the big, the chunks that wasn't covered, that's why the last back scale. That's what you can just do, yeah, that's fine. The 40 milliliters of, each one of the small bit. The reaction is fairly slow, so they want to do that, speed it up. Not really speed up, speed it up. So once you bring it out there, you don't want to boil it because then you want to see what bubbles are the boiling bubbles and what bubbles are the boiling bubbles.
Alright, do you want to wait
And then tomorrow, once it's dried out. Okay, go ahead and start.
The crystals and the.
Exactly, by the back scale there, Chelsea, if you remember.
Oh, okay. Yeah.
Here you go.
So Weiss,
Yeah,
do you think this procedure is descriptive enough or needs to be a little bit more?
how about add, and add to 40 mils. Sit in sounds like you're gonna like take a break and sit in. Findington. Well, first you gotta do what with this crystal?
Measure.
Well, it's gonna be wet.
What do you mean?
It's gonna be wet. What do you gotta do with it first then? That you can then do the final weighing tomorrow. What do you gotta do with it today? Let it do what? It's wet. You can't measure it wet. What can you do with it? Overnight. Don't make it hard, Alex.
I'm not following.
Look, you want to measure this before and after, but afterwards it's going to be wet.
Oh, I
It's been
see.
soaking in
Dry
acid.
it. You gotta let it dry.
Okay, so you want to rinse, take it out, rinse it with distilled water, and then you're
Okay.
going to dry it, and we'll let it dry overnight. Okay? Or you're going to add the drying in here somewhere.
Yeah.
Okay? All right, that's all
The
right.
question, is this enough?
That's fine. That's fine. That's plenty, Penelope. Similar, but not boiling, because once it starts boiling, it's going to bubbles in the boiling. You can't tell what part is what. Is it reacting up? Is it up? Oh, you have to rinse it. Oh, okay.
We not crazy.
Yeah, so you see a little bit, so that's the reaction. It starts boiling, and like, you want to hold it off the side. Yes, now you see the reaction. You don't want to pour it, let's go out the space Okay. As all of you are going, listen just for one question I have. What if at the end of the lab, I have my little crystal of calcium carbonate? For one thing, it's wet, which I talked about already. For the other thing, it's hard to get some wet sitting on it when I take off. A lot of you say, well, I also need solution. What is the problem? I never get it on there. What are the problems? Water, no. No, it is not. What's on it? Look at your products. What other stuff might be on it? Calcium chloride. What are you going to need to do with the crystal? Rinse it off, good. And then it's wet, so get ready for the round of up to. We can put it in the ground oven, but that's not all this is.
Okay, so we wait what's left.
Yeah, you got it, right? By the way, my frequency light bulb, would you like a leaf out? Which thing will leaf out? Kind of cool? Cool.
We are, I think we did the exact same vibe.
You were at that big, huh? Okay, I'll be cool.
That was my second.
This year, everybody else could do it this year. But it's good value that we did it.
I had forgotten.
Okay, good. Well, not good, but
Fine. Nice.
all this coming from the other areas. Yeah, hello, thank you. While you're waiting, you may want to do this. Probably the standard things to put on the ground level. So once you get a bunch of people, in terms of put your initials on the feet.
How do we want to get rid of it?
So once it's neutralized, the solution goes on the center.
We have one person.
And when the exercises do after all, so this is
Although there's probably some chemical that's something, yeah, so it's probably the same that's still in there. So it's not gonna hurt anything, but it's- Okay, start marches and use tools and multiple way up.
I'll follow that guy.
Yeah.
CaCO3 is tiny and it's still growing.
Stop. Yeah, I know, right? Like, yours was so funny. I was like, we need to go to log out every year.
It's all over its shell.
What?
Okay.
So, how are we supposed to dump the liquid without like dumping out the stone?
It'll stay towards the bottom. You can kind of, you can just kind of keep it down there. And then start to rinse
They
it.
can still do like a tad bit.
I can't,
If you're nervous, you can have a spatula and hold it in there.
Yeah,
and then you lift, and then you go like that, and you go like that.
What?
Yeah.
And also don't.
Yeah.
Well, you want that, a new beaker, but that one probably still.
Dirty.
There has. So we just
Got that one right there. Just turn it, turn the handle, turn it.
All right, now we're going to put the board. We just place it in the heater.
Yeah. You poured off the extra distilled, right?
Yeah.
Okay. Okay, then that should be all right. And you got your initials on there?
Here's our leaf lab.
Thank you. Yeah, once you're done, just clean everything up and,
Oh, bro.
any other leaf labs I can take today or tomorrow, either way, all right? Just leave them with me one day or the other.
I don't have any sleep.
You can hold the leaf. We know what it is now, but thank you. Bye-bye.
Have a nice day.
You too.